Next we have example 3. Again, we go back to our chart from the first example. We have both evens, so we're going to be in this bottom section right here. You can work these problems multiple different ways. I'm not going to say it doesn't matter, because you could work it one way and it doesn't work. So for instance, if we were to try to use this first one, we'd have to plug in for cosine squared, right? So this cosine squared would now become this whole thing on the right hand side, but then we're still left with this cosine squared. And the issue with that is we don't know how to easily take the antiderivative of that, okay? So we are not going to do it that way. So that's why we want to use this last one, because it actually gets rid of that squared for us, as you'll see in a second, okay? So because both of these are squared, we're able to pull them into one and just raise it to that 2. And now again, we're using that bottom one, and we can rewrite the inside as a half sine 2x. And then from here, because it's being squared, that means to write it twice. So that means we're going to have a half times a half, which gives us this 1/4 here. And then we have sine 2 theta squared. Okay, so we still have this squared, like I was saying, as an issue. So sometimes it works out, sometimes it doesn't. But initially, but our goal is to get rid of it so we're able to take the antiderivative easily. But it didn't go away, so we have to go back to our chart. So again, we have an even sign, so now we have to use this top one right here, okay? So I guess technically you probably could have tried one or the two first, but it doesn't matter. I think that this bottom one is easier just because it's only one part. So essentially, if it looks like that might work out, I'd use the bottom one. But again, it's kind of just a pick and choose kind of thing, at least from my understanding of it, okay? So at any rate, the only difference from this equation that they gave us is that it's not sine x squared, it's actually sine 2x squared. Okay, so now everywhere that there's an x, we are now going to write 2x. Does that make sense? So over here, instead of 2x, it's now going to be 2 times 2x, which is 4x, okay? So that's where this 4x is coming from. And then this half on the outside, I just moved to the outside over here because it's just a scalar, right? Okay, and then multiply those together, we get a 1/8. And then when we take the antiderivative of this, a number just becomes the variable x, and then we work backwards. So since it says cosine, we know it's going to be sine. The derivative of sine is positive cosine. This says negative cosine, so that's why there's a negative there. We have a chain rule here, which would be 4, which would actually be multiplication, but we're doing the antiderivative, so we divide by 4, okay? And then we just take the integral, we take the top, subtract it from the bottom. Whenever you subtract, you should always use brackets. And then whatever's on the outside needs to multiply by all this stuff. So I would save this 1/8 to the very, very end. When we simplify this stuff, here we get sine of 2 pi. Again, sine of 2 pi is going to be over here. Sine is y, and our y here would be 0, so that goes away. And sine of 0 here would also be 0, okay? So all those cancel out. If this didn't cancel out, it's really, really, really important that you realize that these two negatives will make a positive. And then also, if this didn't cancel out, you'd have to distribute this negative to both of them. So that's why I left the brackets here, just to kind of show you for other types of problems, okay? But at any rate, you multiply this 1/8 and pi over 2 together to get our final answer of pi over 16.